Today we're going to be talking about some properties of algebra, specifically the commutative, associative, and distributive properties. So the commutative property of addition says that basically you can add things in any order you want. A plus B always equals B plus A. For a specific example, 3 plus 5 equals 5 plus 3 because 3 plus 5 is 8, 5 plus 3 is 8. So in other words, you can rewrite the order of addition if you find it convenient. The same thing is true for multiplication. It does not matter which order you multiply numbers in. And so, 3 times 5 is 15, which is equal to 5 times 3 is 15. These seem fairly simple. However, in later math classes, you may need to do formal proofs. And so it is important to define these. All math at all levels is fundamentally based off of a set of definitions, postulates, and theorems, and so it's fairly rigorous. And so even though it seems self-evident now, it is good to know these, depending on, especially if you plan on going further in math. The associative property of addition, associative involves parentheses. Now, I'm not going to say it directly, but if it helps as far as remembering which is which, I'll let you put that together. But basically, associative property says that we can group addition, and it does not matter if we group the last two or if we group the first two, we will get the same result. So for instance, 3 plus parentheses 2 plus 4 is supposed to be the same thing as parentheses 3 plus 2 plus 4. 2 plus 4 is 6, 3 plus 6 is 9, 3 plus 2 is 5, 5 plus 4 is 9. This also works for multiplication. If I have 2 times 3 times 4, that should equal parentheses 2 times 3 times 4. So 3 times 4 is 12, 2 times 12 is 24, 2 times 3 is 6, 6 times 4 is 24. Again, this may seem self-evident. However, it is convenient sometimes to use these properties in order to simplify a problem. So we had earlier a question that looked like 4 times 23 times 1/4. What you can do is switch the order of this, so you can use the commutative property of multiplication. And then you could either do associative property, or you can just do multiplication left to right. So 4 times 1/4 is 1. 1 times 23 is 23. Notice that if we had just gone left to right, we would have to do 23 times 4, end up with 92, and then divide 92 by 4, and then end up back at 23. So when possible, we would want to reorder these. Finally, and this property you're going to use quite a bit, it's the distributive property. Unlike the commutative and associative properties, which have both an addition and multiplication version, the distributive property inherently involves multiplication and addition all in one step. So the distributive property says that if I have a number on the outside of a set of parentheses and I have addition inside, this is the same as distributing or multiplying each of these pieces. Using a specific example, 3 times 1 plus 4 is the same thing as 3 times 1 plus 3 times 4. So if I calculate here, 3 times 5 is 15. Here we have 3 plus 12 is 15. So this is just a specific example just to show that it does work for this specific example, but it is a general property. Now I mentioned addition. It also works for subtraction. So if I have 3 times 1 minus 3 plus 2, I can distribute that 3 to each piece. 3 times 1, and here you can write this as minus 3 times 3, and then plus 3 times 2. So we end up with 3 minus 9 plus 6, so it ends up being 0. If the number outside is negative, you can also distribute it. Although in this case, when you have a negative and you're distributing it to another negative, it is convenient to go ahead and cancel. Now you could write this as plus negative 2 times negative 2 and plus negative 2 times negative 3. However, because negative times negative equals positive, I would probably recommend instead writing these latter parts as automatically canceling the negatives. Negative times negative is positive, so I'd write that as plus 2 times 2 plus 2 times 3. And then again, you multiply it out and you simplify. Now, you may be wondering why we bother with distributive property. We don't generally bother when these are a set of numbers. There is one exception. We will bother with distributive property sometimes to simplify excuse me, certain multiplication problems. So for instance, if I have 32 times 15, it may make sense if I'm calculating it mentally or by hand to break up 32 as 30 plus 2 and then multiply that by 15. The reason is that the multiplication of 15 by these two numbers individually is a bit easier, and then I just have to add the results. 15 times 3 is 45, add a 0, 450. 15 times 2 is 30, and then 450 plus 30 is 480. In some mental math trick practices, you make use of the distributive property in this way, to break up more complicated numbers, do the multiplication bits separately, and then combine the numbers afterwards. But most of the time you will be using distributive property in algebra because the expressions that you have will not be able to be combined into a single thing before you multiply. So for instance, if I have 3 times 2x plus 1, the way I cannot combine 2x plus 1 without knowing what x is. And if this represents a particular thing, I may want my answer in terms of x. So instead, I'm going to multiply it in each piece like I did before. So 3 times 2x is 6x. I'll actually show the step 3 times 2x plus 3 times 1. This is 6x plus 3. Now eventually you may not need to show this step, but initially it might be a good idea. For those of you using counters, I think this is often represented as, okay, I have a 2x here, or rather I have an x here, I have an x here, and I have a 1 here. And I have 3 of those. So I'm going to represent that on this side with a 3. This side is 2x plus 1. So if I repeat the pattern, so this represents the multiplication of 3 times 2x plus 1. If I count the number of x's I have, 1, 2, 3, 4, 5, 6. How many regular numbers, constants do I have? 1, 2, 3. We confirm that 3 times 2x plus 1 is 6x plus 3. Common Core increasingly makes use of these manipulables, these counters, to help represent the multiplication of a number and an algebraic expression, or later an algebraic expression with another one. However, if you get this, you won't necessarily need this. This is just a visualization, another way of conceptualizing. Alright, that's it for the distributive property.